Okay. Yay!
Hey,
There we go.
space piano. Is that like air guitar?
Almost the same. Almost the same.
Almost.
A little lighter.
Yeah. Hey, okay, well, welcome back.
Good to be back.
Welcome back,
Yeah.
everybody that's watching us here tonight. Yeah.
Oh, them. Okay.
Yeah, them
Yay!
too. Yay! Okay. Hello, everyone, and welcome back to our Sunday night offering of Astronomy Outreach for September the 18th now, the Sunday Night Astronomy Show. Yay!
Yay! My hands are getting heavy.
My name is Chris Kerwin. I'm the creator of the social media channels known as Astronomy by the Bay, and I'm an amateur astronomer and member of the Royal Astronomical Society of Canada, the New Brunswick chapter. First of all, I'd like to welcome back our regular co-host and fellow RAS member, Mr. Paul Owen, from the Moonshadow Observatory in beautiful Hampton, New Brunswick. Good evening, Paul.
Yay.
Hey.
Hello there.
And I'd like to also introduce our other regular co-host and fellow RAS member, Mr. Mike Powell, from the PFO Observatory here in beautiful St. John, NB.
PFO.
PFO.
Silent F.
Looking for somebody on YouTube. Don't see anybody on YouTube yet. And just want to make sure
Camera
the stream's up. Yeah, okay, we're up.
All right.
Okay, so then on tonight's episode of the Sunday Night Astronomy Show, now it's that time of year when we feel a change in the air, when sunsets arrive a bit earlier, and we prepare for those long winter nights ahead. Yay!
You're already really.
It is, yeah. It's dark now, right now. Just
Yeah.
because we'll soon be leaving the warm summer evenings behind, though, doesn't mean that we have to stop admiring the beauty of our night sky. In fact, fall presents many new opportunities for astronomers. We get to experience darker skies earlier, which means an observing session can be completed sooner. For those with telescopes, they cool down much quicker, allowing better views sooner. And we're entering into the equinox, the time around the equinox, which is coming this Thursday, which offers its own special facts. Now, in tonight's discussion, we'll look at a few special things about the fall equinox and what we have to look forward to in our fall sky. Also tonight, Mike's going to be bringing back another Binal Bud with another wonderful binocular target of the week. Mike.
Yeah.
And Paul is going to bring us a Rosanna's Fun Fact episode as well, segment as well. And he's going to introduce us to another astrophoto tip of the week. I have two categories for photos to offer tonight for photo submissions. So I have one that was through our normal channels of photos, which I'm going to show first. When we get to that part of the show. And the second is I had asked everybody to send me in your captures of the harvest moon. So I've taken all 135 photos, like this, something like that, like it's a crazy number.
Wow.
And I've put them all together as a collage and a little bit of music in the background. So we'll watch that a little bit later in the show. So that's coming up. So this is a family-friendly interactive live broadcast. So for those of you joining me from my YouTube channel or Facebook page, we're happy to try and answer all your questions related to astronomy in real time as well. And of course, we'd like to welcome back all of those who have been joining us through the local Rogers TV network. Hope you didn't miss us for the last 2 weeks, but here we're back again. Thank you very much for your support. Okay, so let's get started then, guys, with tonight's program and a discussion around fall night's treasures that we'd like to see and a little bit about the equinox.
All night treasures.
Fall night treasures. Who wants to go first?
Treasures in the sky.
Well, I have a night treasure. And in fact, Binal Bud this week just so happens to be in the same area that I'm going to be quickly talking about.
Cool.
So everybody noticed, and now if you get up early in the morning to have your coffee like I do, the winter constellations are actually on the rise, which means the fall constellations are, what we call the winter constellations. The fall constellations are up now, or starting to come up. So one of my favorites that come up, I'll just share my screen here, is, ding. Did that come up? It looks like it might have.
It did, yep.
Is Auriga. And I'll tell you why. There's a lot more in that big pentagon than meets the eye, that I can say. So when you look up right around where just last night or the other night the moon was up, you saw the moon, the Mars, Aldebaran were all together. And then a little bit further to the east, there was a bright star Capella. And it's very bright. You can't miss it. And that is the brightest star in that constellation, Auriga. Now, what is there to see in there? Well, there's three major Messier objects. There's 1, 2, and 3, as they're labeled on this little picture, are Messier 36, 37, and 38. And they're all open star clusters. Very easy to see, actually, in a pair of binoculars, believe it or not. But then I got looking around to say, what else is up in there? Well, there's a whack of double binary star systems and binary star systems that, man, I didn't realize actually they were there. I've looked around it, but I wasn't looking for these specific targets. And they actually named some of these things. Like Capella is called She-Goat, which is a double binary star system. And it's bright. It's a 0.08 magnitude. I can't even pronounce half the names of these stars, but I mean, the wrist, the end of the belt, the He-Goat, the middle of the belt. So all of these up in Auriga are all here for you to look at. Real easy target in binoculars. And of course, you get your telescope on some of this stuff and it'll start blowing you away. There's the yellow giant stars in there. There's a red giant star, number 14, which is right in here. I mean, who knew that these different items were in there? I didn't until I come across this photograph and went, holy geez, I didn't realize all that stuff was there. I know M36, 37, and 38 are there because they're one of the three targets I go to the most in this time of year, just to, they're beautiful open clusters. And when I show you something on Bino Bud tonight, which is just a little bit around M36, you'll understand why I look up in that area and why I like it so much. But Auriga starts to rise, I think, just after 10 o'clock. So to really, unless you're on, if you got a hill or trees or anything around you, you got to wait till about midnight before it's up high enough for you to really get a good look at it. But I call that one of the fall constellations that I like to look at the most because it's just it's a beautiful area. Lots of different things all in that one little spot for you to look at. And it's real easy to find. I mean, you come down from Cassiopeia through Perseus and bang, there's Auriga. And the same with if you look up and you see the Pleiades and Taurus, well, Taurus comes up and touches the bottom of Auriga. So it's a real easy constellation to find and lots of good targets in there to look at. So that's my little spot on that section of the sky.
Awesome. Thanks, Mike. Auriga is a good spot to be sitting around looking at.
Awesome up there.
Awesome up there. Mr. Paul, what do you got to add?
All right, so I'm just going to show a site that's actually on the Celestron site, and but it's a really, really cool site to visit for a lot of reasons. But let me share my screen and talk about it, but you won't be able to see it. Okay, so basically, if you go to the Celestron site, you can look at telescopes, astronomy, sport optics, and all the stuff that they sell. But they've also got this really cool section in there where you can actually see what's up in certain times of the year. So this is called the Ultimate Guide to Observing the Fall Sky for the Northern Hemisphere. And then so it goes into talk a little bit about, what happened in the summer and the fact that we're starting to get into the darker skies earlier and so on. So then it starts off with popular autumn constellations and asterisms. So, for example, Aquarius, and so people say, well, most popular constellations are best seen mid-September and until the end of the year. And these include constellations of the zodiac, which is where the names come from, because a lot of people wonder, where do they get the names for these constellations? So they kind of put a little story in there. I'll just do Aquarius, just to give you an example. Known as the Water Bearer, Aquarius is a large constellation covering 980 square degrees. It is bordered by the constellation Pegasus, Pisces, Cetus, Sculptor, and Pisces, Austrinus. And Aquarius is one of the 13 constellations of the zodiac and resides in the area of the sky where the annual Delta Aquarids, did I say that right? Aquarids? Aquarids, the meteor shower takes place in the early mornings hours of late July. And then it goes ahead and it shows you basically what that constellation would actually look like. For the mythology, for Andromeda, in Greek mythology, Andromeda, the princess daughter of Queen Cassiopeia and King Cepheus, was chained to the rock waiting to be Cetus, Sea Monster's Dinner. And then it goes in and tells you a little bit about these stories. So there's lots of times when people talk about this stuff, a lot of people like the folklore, and there's a lot of different variations of it. But anyway, so they include a lot of that in there. So that's kind of cool. So it runs through all the really cool fall constellations. And then once you get down into here, then there's the top autumn celestial objects. So there's actually objects within the constellations that they go to talk about. For example, Andromeda Galaxy, the double cluster, the ET cluster, Messier 15, 33, 34, and it goes on and on and on. And then there's other notable celestial events as well, like Mercury at the greatest eastern elongation, the harvest moon, of course, that we're coming up to on the 20th, I guess. Anyway, so there's all kinds of stuff in there, and then there's on the bottom of it, it talks also about the helpful hints, helpful observing hints. You know, about bringing a star finder, knowing that it's cold to dress warm. If you're using a telescope, make sure the optics are collimated, and all of that kind of stuff. And then it gets into some of the things, of course, that they sell, which is, you know, which is cool because it's nice to know there's a place to get this stuff. And so it's a really, really good page for those who are getting into astronomy, or those who are but want some reminders of some things that they can look for this time of year. And it's on the Celestron site. So that's what I want to show for those folks who didn't really know where to get started. Just go to that Celestron site, and there's tons of information on the fall stuff.
That's a great page, Paul, for sure. Yeah,
Yeah.
a lot of stuff in there. If you wanted to study just a particular constellation, you've got all that data right there. So data, yeah, awesome.
Yeah.
Okay, I'm just going to add one thing that I kind of like looking at, and I guess probably most people know that anyway. My table's shaking a little bit here. It's not an earthquake. It's not an earthquake. Okay, so let me share my screen back here again. And first of all, before I start at that, I wanted to say hello to my brother Danny out there, who watches our show every single week, has been a faithful watcher for 145 episodes now, first of all. So, hey, Dan. And also, my son Paul Arthurs is here from Winnipeg. He's joined us as well. So,
hey, hello.
Paul has helped us an awful lot to get us started on the program, get us set up and stuff, and has continued to help us right along. So, welcome. Okay, so let me take a look at it. Let me show us one. Just bring up here. Was this one here? So this is one I've referred to before in other talks. You guys are seeing that okay?
Yep.
Okay. Oh.
Nope. Yep.
Yep. Nope. Why does that anyway? So this is the planet summary page that is on Heavens-Above website, and they have an awesome amount of information on this page as well too for reference material. I look at planets, of course. That's what I get asked about the most. Where is Saturn? Where is Venus? Where is Mars? And this is what's happening as of today's date. So if we look over here, we'll see that right now Mercury rises at 8 o'clock and sets at 7:22. So it's a tough target. I think sunrise is actually a little bit past 7:22 still. So it's getting close anyway. We might be able to get to see Mercury shortly in our evening sky. Venus sets again at 7:13, so that's just about impossible. But Mars, it's up at 11 o'clock now and doesn't set till 2 in the afternoon, so that's visible. Jupiter is coming to its best viewing, actually. It rises at 7:51 and doesn't set until 8 o'clock in the morning. That's because if we follow this line straight down here, we'll see that it actually becomes at opposition on September 26th. So that's getting pretty close. So that means that the Sun, Earth, and Jupiter are all in a line. So when the Sun sets, Jupiter rises. When the Sun rises, Jupiter sets. So it's up all night, right in the highest in the south at midnight. Okay, so that's Jupiter. Saturn is still with us. It's rising right now at 6:10, which is really early. So yeah, as soon as the sky gets dark, you've got a chance to view Saturn right away because it's already 2 hours up by the time it gets dark. It doesn't set till 4 o'clock in the morning. We're not going to talk too much about Uranus and Neptune because they're just a soft ball if you're looking at them in the evening sky. They look like a star, but not quite as pinpoint. What I've seen, anyway, all I've ever seen is just a softer kind of a ball of that color. But anyway, we've got Jupiter, Saturn, and Mars for sure for the next little while. Saturn probably till the end of October, and I think Jupiter is right into November this year. which is nice. So that's what I would like to say for my choices for winter time or for fall targets. And I know a lot of people like viewing Saturn through the eyepiece for sure.
Yes, sir.
So
Yeah, Jupiter. Who was talking about that? Chris Go, I think, or somebody like that, who shoots Jupiter extremely well. And he was saying that now's the time if you want to take pictures of it, boys.
Well,
I mean, you've been seeing some really nice stuff anyway.
yeah.
Yeah.
So Jupiter's the fourth brightest thing in the sky anyway. The Sun, the Moon, Venus, and Jupiter. So when it comes up in the eastern part of the sky, there's no mistaking that that's what it is, right? It's a really bright object in our east now.
Just where it's positioning itself.
Right.
And of course, when you want to get it as close as you can to the meridian if you're going to shoot it.
Right.
Because that'll be at its highest. Anyway, so.
Right.
But anyway, there's some stuff going on with that. I've seen some photographs from the crew that Mike hangs with. Some really, really nice Jupiter pictures coming out.
Oh, they're coming out with some nice stuff,
Yeah.
Okay, I'm just going to talk quickly about the equinox because that's coming up this week. I'm going to share again my screen. And let me bring up my little 5 or 6 slide presentation I got going here. Okay, so the equinox, of course, is what's coming up very soon. I believe it's Thursday. I think it's 10 p.m. for us, Atlantic time. Or the autumnal equinox, you can call it either one, the fall equinox, autumnal equinox. What is that all about? Well, the fall equinox is really the moment when the sun crosses the celestial equator. So the sun's going south now, an imaginary line above the Earth's equator. Now that this year, that date and time is Thursday, September 22nd at 10:04 Atlantic Daylight Time. Now to us, that is the first moment of fall or autumn. So the sun is saying goodbye for a while. Now, there is 2 different things though. I did find this out just today. I kind of didn't understand what this all meant, but I kind of get it now. It's the equinox versus the equinox. Equinox versus the equinox. So it used to be stated that equinox meant equal day and equal night, and that's what we all think it as, but it's not really true as shown by the table supplied here by timeanddate.com. So if the 22nd is actually the equinox, and it means that it's equal day, equal night, we can look at the length of the day here. It's actually 12 hours and 10 minutes and 24 seconds. So that's not 12 and 12. We have to go all the way down here until we hit the 25th before we get close to 12 hours in length. So it can actually be a few days to a few weeks in difference. A couple of things affect this now. The length of a day is calculated by the time the sun's upper edge touches the eastern or the western horizon. Now, if we were to use the sun's geometric center, instead of the top edge, the length of the day and night would actually be the same on the equinox. Now, another reason is because the Earth's atmosphere refracts sunlight. So when we see the sun set, it's actually already set, but we're still seeing sunlight refracting around the atmosphere. This refraction or bending of light causes the sun's upper edge to be visible from Earth several times before the edge actually reaches the horizon. Now, the same thing happens at sunset when you can see the sun for several minutes after it's dipped under the horizon. This causes every day on Earth, including the day of the equinoxes, to be at least 6 minutes longer than it would have been without this refraction. It also depends on your latitude, and equinox can be a few days to a few weeks away from the equinox. Kind of neat.
Wow, that's interesting.
That's timeanddate.com tells us that. So, but a few kind of cool things about the September equinox, what we're going to enjoy anyway, is that as the equinox rolls by, the chances to see aurora borealis display increases for those of us located at the higher northern hemisphere latitudes. Now, according to NASA, the equinoxes are prime time for northern lights. That's because geomagnetic activities are twice more likely to take place in the spring and fall than in the summer or winter. And of course, add to this the fact that our sun's activity is now increasing. We're heading towards solar maximum in 2025, and it should provide some good opportunities for aurora viewing pretty soon. So that's always good. Another thing about the equinox is how it's related to the ecliptic. And that ecliptic is a line that the moon and the planets seem to take across the sky. So at this time in March, the ecliptic line is very steep. We can see it here, very steep. And in our time of the year right now, it's actually quite shallow. So many of us have enjoyed the bright orange color of the harvest moon recently, and that it seemed to stay that color longer. Well, in the fall, the angle of the ecliptic, or the path that the moon and planets take across the sky, is very shallow with respect to the horizon. Now, this means that instead of the moon rising about 50 to 60 minutes later each night, it now rises only about 30 minutes later each night. It also means that the moon stays near the horizon longer, so the moon's light has a difficult time punching through the thick atmosphere near the horizon. As light gets broken up into all the spectrum of colors, it is the red wavelengths that make it to our eye when the moon is near the horizon, so we can see or experience several nights of bright orange moons for longer periods of time. The equinox is actually celebrated across the world. In fact, back in the Mayans' time, they really celebrated the equinox. Now at Chichen Itza, during the spring and fall equinoxes, this pyramid dedicated to Kukulkan serves as a visual symbol of the day and night. Now on every equinox, the sun of the late afternoon creates the illusion of a snake creeping slowly down the northern staircase. Now symbolically, the feathered serpent joins the heavens, earth, and the underworld day and night. At Chichen Itza, during the spring and fall equinoxes, this pyramid dedicated to Kukulkan serves as a visual symbol of day and night. And we're going to go to a little bit of video that I have that shows it. So let's quickly look at this. And you can see how the shadow is changing here. As it looks like a serpent. And the head, of course, is down below. We're going to see that in a second. There it is right there. There's the big head. So that happens only on the spring and fall equinox.
Oh, that's very cool.
That's kind of neat. So I guess that's it for that.
I was going to say it's a shadow of its former self. But that's okay.
Wah, wah. There. So that's a little bit about the equinox. I didn't realize that they were that far apart, though. Really, the 12. I thought it was 12 hours and 12 hours, but
yeah.
Yeah.
It showed a difference of 3 minutes, I guess, or something, eh?
Up to 10 minutes at right on the equinox.
Yeah, the time that was supposed to be the equinox, and then the equinox. Is that what you said it was?
Yep.
Yeah, it was about 3. It said difference on that column.
Yeah. Well, that meant that each day was getting 3 minutes shorter. That's what it meant. You're losing 3 minutes of daylight each day.
Okay.
Yeah.
Okay.
Each day we're losing 3 minutes of daylight right now.
Wow, that's fast.
That's a lot. Yeah.
Yeah.
Okay. That's that part. Where are we going next? Where are we going?
In 10 days, that's a half an hour.
Yep.
Who, where, what?
No, in 10 days, if you're losing 3 minutes a day.
Oh, yeah.
In 10 days, you lose a half an hour.
And
so you're losing that's really
substantial.
fast.
Yeah.
Yeah.
Oh, yeah.
Substantial. And I think it increases each day. I think it's up to 4 minutes, I believe. And then we start kind of
Going the other way.
Yeah.
Yeah.
Takes us quite a while to get the other way, though.
Yeah.
Oh, yeah.
Yeah.
All that snow stuff. Okay. Let's go with Bino Bud next. How's that?
Sure.
Paul says, I heard that you can balance an egg on its end at the exact moment of the equinox. I'll give it a try. Does that mean a hard-boiled egg or a raw egg?
An Easter egg or a chicken's egg?
I'm going to stay up and we'll do a live feed showing it there. I like it. Good idea.
On that note.
Yeah, okay.
we wouldn't want to have egg on our face.
No. Wow.
Wow.
Sorry for Dad, yo.
Wow. Yeah.
That'd be a first.
Yeah.
Binocular target of the week this week by Bino Bud. And this is up in that same area I was talking about in Raji earlier. It's called the Leaping Minnow. Woohoo!
Hey.
Alrighty. So the Leaping Minnow asterism is an informal grouping of stars that includes 14, 16, 17, and 19 Auriga. If you include the water splash, there are 30 or more stars of 9th magnitude and above, with the minnow itself being defined by half a dozen 5th to 6th magnitude stars. If that means anything to you, good, but see if we can figure this out. How do I find it in the sky? Well, if you went out at 1 o'clock in the morning because you're an astronomer and you stay up late, you orient yourself 65 degrees east-northeast, you look up in the sky and you'll see Auriga. And it's the big pentagon up in the sky with Capella being the brightest star. You look down around the bottom part of it here and see this little dot right in here that looks like a dolphin? That's a leaping minnow.
Oh, there it is.
It's like a mini version of Dolphinus. How's that? And then M36 and M37 make the splash of the water. So right in here is the leaping minnow, right? And M36, sorry, over here, M38. And the leaping minnow goes in and splashes into that section. Here's what it looks like. There's the leaping minnow, the blue stars here, and there's the water that he jumps into. So it's kind of like flip, splash. There's Capella. The bright stars make up that big pentagon. You can't miss it. So it's a huge target to see in binoculars. It's over here in the corner. You can't miss it. In fact, 10 by 50 binoculars, this is what you're looking at. Look at that.
Oh, that's huge.
It's a good size, real easy to spot. There's M38. It kind of starts this water splash that the minnow's leaping into. And that's why they call it the leaping minnow. Compared to the full moon, well, the leaping minnow itself is at least the size of the full moon. If you include everything else around it, you're talking 5 full moons in that area if you're looking at the minnow and the supposed splash. So, you know, they could have called it the flying coffee cup. That's Bino Target of the Week by Bino Bud.
Thanks, Mike.
Well, that's a new target. I've never seen that.
Yeah. That isn't a
Well, you did 52 weeks ago, actually, because I was Bino Bud 52 weeks ago.
Wow.
Well,
I guess you didn't remember it.
There you go. That's our age.
I have to say, Mike, you said Delphinus.
Delphinus, I got it right for once.
You did. I like Delphinius better. Sounds better.
Yeah, well,
It's more fun to say.
It is.
Yeah, you make up your own. Why not? As long as you can find it in the sky.
That's your.
Same with the Tim Hortons constellation, right?
I love that.
That's right.
I love that.
Yeah, that was a good one.
That was a big hit at the Star Party.
It was.
Oh, yeah.
I forgot to credit you for that too, Mike. So.
Yeah.
That's all right. As long as people looked at it, that's what counts. They recognize it.
Mm-hmm.
Yeah.
Okay. How about we do a Rosanna's Fun Facts, Paul? Are we ready for one of them?
We can do that.
Great.
As soon as I put the music back. All right.
We've all been having some computer trouble here the last week or so.
Yeah, well, I guess we both have, hey?
Yeah. The desktop crashed twice and that I've been running the show on. Laptop quit. I'm kind of doing everything on my phone.
You guys are in those sites you're not supposed to be.
Rosanna's Fun Fact.
Yay. Welcome back, Rosanna, to another great fun fact. And this fun fact is actually going to be lots of fun. We haven't been able to do a fun fact in a couple of weeks, so Rosanna really upped the game for this one. So she says, hi, Paul. This fun fact is dedicated to the weird and wonderful aspects of the world that we live in. A couple of years ago, an exciting chemical signal was discovered by an astrobiologist, Jane Reeves. Now, Jane led the team that announced that the discovery of phosphane. Phosphane can be a byproduct of living things, so finding it in Venus's clouds could be possibly indicate something alive floating around the planet. Now, Venus' surface is totally inhospitable, but there are regions in the cloud decks where temperatures and pressures are smaller than those found on Earth. In her talk, she included images of, let me see if I get the right way on this one, I get this correct. There we go. Images of penguins' tummies are other spot one can find phosphine, which means you can also find it in penguins' poo. Unfortunately, or fortunately, depending on your perspective, this led to confusion for some, leading to this. So the scientist claims that penguins might be aliens after discovering chemical from Venus found in the bird's feces. Researchers are confused how phosphine was found in penguins. Now, the discovery of phosphine led to the meme after meme about the life on Venus, enough that Jane in her talk, check it out, and it's really interesting, had to specifically state that we did not, in fact, suggest there are penguins flying desperately, flapping above the surface of Venus. There's actually a whole document on this. It's a how do you say it? Yeah, it's a documentary on this thing. It is it's I don't know. I'll post it on the thing. You can so they can look at it. So so if you scroll into the minute of 1850 on her talk, you will see that the images she uses that stated that the penguin ball started the penguin ball rolling. Below is a possible explanation of how quickly the world goes nuts. Scientists versus media. Now, check this out. we found phosphine on Venus. On Venus? We found phosphine on Venus. We found life on Venus. And that's the way it goes. Another very weird thing that popped up in my inbox was a story about butter. Now, what on earth does butter have to do with anything space related? Well, this. And this.
Wow.
Yes, Virginia.
Wow.
These amazing sculptures are made of butter. 2,200 pounds of it, to be exact. In honor of the 50th anniversary of the Apollo landing, Paul Brook and Alex Bolts created this fantastic sculpture, which took 400 hours, and 4 additional sculptors in a 46-degree room. That's a cool room, of course. They also included a tribute to the source of the butter. Talk about a moon landing.
Moon landing.
Really not my joke.
You were saving that one, weren't you? Yeah.
That was Rosanna. She put that in there. I'm just reading it.
I thought that was the other story. There.
Now, in case you were wondering, the butter used was past its expiry date, and after the exhibition was over, it was recycled into animal feed, tires, cosmetics, and biodiesel. I felt great relief after reading that. I got to give you one more angle.
Wow.
That's crazy.
So, hilariously, lest another media interpretation gets launched, this picture was accompanied by this statement. The sculptural montage is not historically accurate. No cows were present at the moon landing. This is from the American Diary Associations in the Mideast. And just in case you were wondering about penguins and their future in space exploration, not much in spaceport. And that is
Rosanna's Fun Fact.
Yay.
Awesome.
Oh, wow.
That is, I just love her fun facts. They are so
That's hilarious, man. That's cool.
unbelievable. I don't know where
Derek says another punny episode. Pardon the pun, he says, yeah.
Oh
Awesome.
my gosh.
Thanks
you so
again,
much,
Rosanna.
That
Yeah,
was
wow.
really, really entertaining.
All that
It
work
really-
for butter.
That one is smooth as butter.
It did.
I'm thinking about bread and butter
I'm
now.
thinking about popcorn now, yeah. Take a corn of the
I
cob and
can't
rub it
believe it's
inside it.
not butter. Yeah.
That's
Oh,
something
good.
else. She always brings the most challenging topics.
She's always
my
trying to
God.
butter us up.
I think so.
Oh,
Oh. Okay, let's get out of that topic quick.
Uh,
It's going downhill real fast. Okay, let's get to some photos then. I guess if I can open up my folder. And I could open up this folder. I can get the words up here. Okay, let's.
you, oh.
Hmm?
Sorry, just pressing buttons.
Okay. Okay, let's share a few photos that were sent in as submissions to the page, or the address, I guess, and we'll share that address afterwards. And then later I've got some photos to share that were all part of the Harvest Moon ask. Okay, let's get my photos up. We'll start out with this one here. I'm going to get it lined up here first of all. Where's it at? Come on. There it is. Okay. There.
Nice.
That one's come from Jamie. Why not? So Jamie says, "Hi Chris, welcome back." She says, "I spent most of my summer exploring the night sky with my binos, but finally got my scope out on September the 7th and turned it towards the 92% waxing gibbous moon and of course Jupiter." She says, so get Jupiter up right there.
Oh, very nice.
Wow.
Nice, huh? Well done, Jamie.
Well.
Looking forward to the end of the month for opposition. Yeah, that's coming up. We mentioned that earlier, so that's coming up pretty soon. Good stuff. Okay, we're going to go from there to, thank you for sending that in. Carol Bean sent this one in.
Oh, that's cool.
See, that's
Nice.
last night's moonrise. That was back on September 7th. Now, I'm getting some photos from back a little bit because we've been off the air for a couple of weeks. Now, lined up with the lamp on the wharf in St. Stephen. Very nice.
Moondrops.
Yeah, she's got an amazing eye for some of the stuff she submits. Thank you, Carol. This one come from Duckman Arsenal. Nice moon, daytime moon there.
Yeah.
Oh, wow.
Fort
That's
Howe.
remarkable. Yeah.
And this one as well, the moon behind the clouds on September the 12th.
Yep.
And that one as well.
Oh,
Very
nice.
nice.
Well done.
Thanks, Duckman. I don't know what the guy's real name is. He just calls himself Duckman. That's okay.
He's a quack.
Yeah, he's a quack. Quacks me up.
Oh my.
Well, okay. Oh, these one come from Matthew Dupre. Hey, he says,
Mars.
hope you had a great vacation. Here are submissions, some submissions. One I got of Mars a little over a week ago.
Nice job there.
A nice,
Very nice.
yeah.
Nice detail.
Hard to get detail on Mars. Yeah. And the other one is of the moon. So great shot of the moon.
Very
Look at that.
Yeah.
There you go.
There's a little moon. That's not nice.
That's really cool.
Very nice.
The coloring of the moon is really difficult to get, but once you get it, it's
Yeah.
you never
It
really,
really-
you never really think about color in the moon, do you?
No, no.
Yeah, Apennines right there, and there's Apollo 15 landing site, and there's Copernicus, and ooh, beautiful.
Very nice.
Okay, thanks for those, Matthew. Jeremy Costain sending a couple of shots of the sun and the moon.
Oh,
Isn't
nice.
that kind of shape, eh?
Hmm?
Did you see that shape?
Yeah.
That one there.
Yeah.
Or the other, yeah. That's different.
Yeah. I wonder how low that was in the sky when it was shot.
Have to ask him. Maybe he's on here. And there's his other one.
That's
Thank
fair.
you for those, Jeremy. Corinne McDonald sent this one.
Oh,
Beautiful.
That nice, huh?
Beautiful.
Very nice.
Yeah. Fort Howe, I would assume.
I would think so.
Yep.
She said first shot September 11th, Fujifilm X-T4 ISO 160, 49.4 millimeter f13 at 10 seconds.
Wow.
Beautiful.
Lots of detail, yeah. Wow,
Nice shot.
incredible shot.
Fantastic. Yep.
And her second shot is here, waning gibbous moon, 76%.
Yes, sir.
Shot with
Ooh, very
Fujifilm X-T4 ISO 160 f8, 1/1250th of a second, 600 millimeter lens, processed in Photoshop.
Very nice.
Well done.
Yeah.
Thanks, Corinne.
She confirmed it is Fort Howe.
Yes, she
Yep.
is. Thank you. All right, great shots.
Beautiful.
Yeah.
Here's one from Raymond Kwong. Raymond sent this one, a dark nebula, Barnard 142 and 143.
Yep.
Collecting, showing up as the letter E. There it is there.
Yeah.
Near the bright stars Altair and Tarazed, in the constellation of Aquila. Hey, Aquila.
Very nice, eh?
Tequila.
Can't be singing.
Yeah.
One of my frames captured a meteor passing by, blending it into
Yeah.
the stacked
Down the
image.
bottom.
Yeah,
Yeah.
Nice
right
shot.
there. So yeah,
Beautiful.
great stuff, Raymond. Thanks for that.
And no starlings.
And no starlings, yeah. Amazing. That's not going to happen often. Very nice. Okay, we're going to go over to
wow.
Brad. Here's Brad Perry's shot. See, on my monitor, it doesn't look quite as nice as it does, I'm sure, coming off the screen, but my monitor's just coming out to me. You guys are getting a different feed, so that's great.
That's gorgeous.
He
That's
says,
nice.
Hello, Chris. I hope your star party last weekend was a success. Here are a few photos from the past couple of weeks. I have shot of the Milky Way from August the 28th, taken about 50 kilometers north of Fredericton, near a friend's camp where the sky is a bortle too. Nice.
Yes,
Yeah,
sir.
very
Look at
nice.
the prancing pony standing right out.
Yep, right there. I can't not see it now.
Wow.
Yeah, no, it's there. Good job.
And then he's got these two. The other
Uh-oh,
two
Aurora.
photos he says are of the aurora on the night of the September 3rd and into the morning of the 4th. Now the shot with the Big Dipper right here was taken around midnight, and the other one was at 5 a.m. he says. Look at that.
Wow.
Wow.
Yeah.
Very nice.
So it seems like it was going strong all night, both taken at the end of my road in Durham Bridge.
Wow.
Well
Really
done.
nice.
Yeah.
Yep.
That's gorgeous.
I love sharing photos on here. This is one of my favorite parts. And I'm watching people as they progress through the hobby, right? It's amazing to see some of the earlier images, and then as they progress to shots like this, like, you know, it's been incredible to watch, and it's nice to watch.
Oh,
I've got these ones from Angela Michaud, some moon shots here.
Oh, nice.
Hey, Angela,
Oh, beautiful.
nice. Thank you for those.
Yeah.
And I think finally is Bridget Green sent this one in. This guy.
That guy. Chicken eggs.
That's it. She says, "Hi, Chris. Hope you had a nice break. I'm sure you received an astronomical number of photos from that weekend. No worries if you don't get to include it on show. Well, let's hear it, Bridget. Wanted to send it as it stands out for me because I took it when you were demonstrating something, perhaps related to the Earth axis, to a young girl and her mom. I wasn't able to retain the concept, but what I do remember is your passion and the curiosity of the girl and her mom. I thought it was very special. Now, that couple there came down from Toronto.
Oh, that's great. Yeah.
That's them, yeah. They come all the way from Toronto just to see our star party. So
Really nice couple,
that
too.
was amazing, yeah. And she's really getting into astronomy and thinking about going into the, you know, right into the career of it. So I was trying to convince her to go ahead. But it was, yeah, that was a great weekend. Amazing amount of people. Really nice to get back out again to share the night sky with everybody. Nice to talk to people like these nice folks
Oh, yeah.
to get their ideas. And I love talking to younger folks to see where their heads are and what direction they're going. Right, try to encourage people to get into the STEM part of the hobby for sure. So thank you for that, Bridget.
Yeah.
Very nice. And I guess I just got the one more. So this. If you have photos that you'd like to send in to us, you can send them into SNAS at astronomybythebay.ca, or you can also send them into SundayNightAstronomyShow@gmail.com.
Yeah.
And we thank you for all your photos.
Oh,
yeah,
yeah.
we're getting better. So I mean, all the time.
Oh, yes, absolutely. Love that part of the show. Okay, we're going to go from there to Paul's astrophoto tip of the week.
Oh, okay. Well, it's actually not so much a photo tip of the week. It's more or less just.
I'm ready.
Well, we're not going to be using that.
Oh, okay.
So what I wanted to just talk about this week is because a lot of people will be getting their telescopes out more now because it's getting darker earlier. And a lot of people who have telescopes, and specifically a German equatorial mount, the first thing that you have to learn to do with that, or if you ever decide you want to get into astrophotography and doing deep space astrophotography that requires guiding and or exposures that you're going to be at a target for a long period of time, you have to know how to line up your mount properly with the North Pole. Once you learn that, that is probably the largest foundational thing you'll need to get into astrophotography. Or if you want to find targets easily with your computerized telescope, the better you are polar aligned, the easier setting up your computer is once you've got that part done. So having said all of that, let's just jump right into what I was going to talk about. Whoops, wrong one.
Oh, let's save that for next week, Paul.
Wrong key.
And we're live.
Where did I put that thing? I lost it
Oh,
again.
fun fact.
Oh, fun fact. Yeah, where did I put it? Oh, no, is that it? No, that's not it.
No, that wasn't it.
There it is. I found
There
it.
it
Hey, you're right.
Okay, let's get that open on my screen first of all. And it's over on the wrong screen. It always is. I'll put it over here. Okay, and what we're going to talk about, I'll share my screen now, is polar alignment.
There she be.
There we go. So,
well, this is pun week, isn't it? Yeah.
it's
Must be.
pun week. Well, we've been off, so we've had 2 weeks of trying to get back into the joke.
Tomorrow's pun day. Yeah.
I can hardly bear it.
Barrett. Yeah.
Anyway,
Oh, boy.
so yeah, polar alignment. So here we go. I'm going to get out of that screen, hopefully, and get into another one. You just give me a second here to get that set up properly, because my screen isn't where it should be. And where is number 1?
I don't know. The cormorants were doing the same thing the penguins were doing on Venus.
Oh, I got some lines for that afterwards. Okay, so basically, German equatorial mount. So what is a German equatorial mount? Very, very simple. It's the same as an alt-az mount times 2. That's really what it is. So a German equatorial mount has an alt-az system on the bottom, which means that you can move your scope side to side and up and down. And also on the very top, it has the same thing. You can move your scope side to side and up and down. So there's basically 2 alt-az systems on a German equatorial mount. And very importantly as well, what you won't find on an alt-az mount is what they call a polar scope. So at the very end of this telescope, where that little cap is, that will unscrew. And there's actually another telescope right in there. And that particular telescope's got some markings, which we'll talk about. So first of all, why do we need a German equatorial mount? Very simple. The sun, as Chris pointed out earlier, rises in the east. So if you look at, if we were standing right here in the center of this circle, to our right, if we're facing north, would be east. To our left would be west. And of course, straight ahead is north. So the sun, if you want to know what is east, always rises in the east and sets in the west, the same as the moon and all the planets. So, so alt-az is very simple. Basically, it is, if we're, again, facing north, south, east, or west, what azimuth does is it moves it either towards east, towards west, so side to side. And what altitude does, or the alt, they call it, raises it up and down. Now, in the northern hemisphere, where we are located, here in the, say, most of the New Brunswick area, we're at 46 degrees. So we're standing from here 46 degrees up, and that's where we're going to find our North Star, or Polaris. So what will you see when you look through a finder scope or a polar scope? So when you look through a polar scope, this is what you would see. Remember that how I showed you on the telescope? That's got that cap. So if you pull that cap off, then you're going to see this. This is what you're going to look through, and that's called a polar scope. So in the polar scope, you're going to see 2 constellations for the northern hemisphere. We have, of course, Ursa Major, Big Dipper, and we have Cassiopeia. So what you do is when you look through your polar scope, is you look up in the sky, because you get your scope pointing pretty well north, and you're going to see where is Ursa Major, or the Big Dipper, positioned, and where is Cassiopeia positioned. Once you see that in there, chances are it won't be the same as what you see when you look through your polar scope. So what are you going to do? You're going to take your telescope and you're going to move right ascension. You're going to move your telescope. And what I mean by right ascension, you see how it's going up and down like this? You're going to move it one side or the other like that. And then what's happening is you're actually turning that polar scope. So you're going to do this to your mount until you see that what you see in the sky lines up with your what you see in the polar scope, which is, again, the Big Dipper and Cassiopeia. So again, once you've got that spun around, chances are this will be in a different position. And if this moves, this will move, because the whole thing rotates, of course. You'll notice in the center where it says NCP, that is the northern celestial pole right there. Notice that Polaris really isn't on it, because Polaris is not at the northern pole, but it's the closest mark that we have to that we do our alignment with. And you'll notice on the circle on this that there's a little tiny circle again. Well, when you see that, that's actually where Polaris should be in relation to the Big Dipper and the Little Dipper, no matter how you spin it, because everything rotates, including Polaris. So there's an app that you can get, and it's called Polar Finder or Polar Finder Pro. And what it does is just an app that will show you on a circle, which is the very same circle that you see here. it will show you where Polaris should be. Then all you have to do then is basically you move your mount. And I'm going to show you how to do that. So on your mount, there are basically azimuth bolts, which are these bolts here. So if I was to turn this bolt this way, it's going to pull the mount towards that particular bolt. If I spin the bolt that way, it'll pull it to the other. So just like on that circle or that illustration I showed you with the poles on it, it just moves it in azimuth. So it's basically side to side. That's the side to side movement. Now, to get the proper height, we have to, on your German equatorial mount, whether it be something like this or something like this, there are two bolts on your mount. And what these bolts do, this one here is the one that actually rises the telescope, so you can get at that 45-degree angle that you need to be to point at Polaris, or whatever your particular angle happens to be where you live. And then the other one basically is to lock it in. So the 4 bolts in the front that you need to adjust are the 2 that are on the front and the back, which are for the up and down movement, and the 2 bolts that are on the side to side, or on the side rather, to make that side to side motion. Once you've got that in position, then that circle that you looked at in the beginning on your telescope, as you can see here where Cassiopeia is and where the Big Dipper is, now you can see that we've almost got Polaris in that circle. So for observations, that's close enough. If you're going to get into astrophotography, you want to get closer again. So that'll be the outcome of what will happen after those mount movements. Whoops, sorry. And the other thing I want to point out was on this photograph here of this mount, a polar alignment is not the same as a computer alignment. And I want to make this clear because a lot of people get those two things confused. A polar alignment is using the bottom half of your mount to basically line up the mount with Polaris. It stays there stationary all night. That part of the mount does not move again. The top of your mount, however, does, as you slew from target to target to target. And then what you do after you do your polar alignment, that's when you do what they call a 1, 2, or 3 star alignment, or a solar system align, or whatever alignment system that you happen to use. And that's how you will line up the computer. That's how you tell the computer, where are we on Earth, so that when I tell you I want to go to a target, you know exactly where to go. So those are 2 different alignments. But the one that we talked about tonight was the polar alignment, and that's the one that you have to do first. Learn that, and then you are 3/4 of the way being very comfortable with a German equatorial mount. And that's my chat.
It's awesome, Paul. I don't understand a word you said, but because I do alt-az. Look, alt-az.
And Alex D75 has never seen night.
Might never yet. It did one night. Remember, I set it up in the backyard. We were showing.
This is true. And we walked you all the way through it step by step.
I forgot it as soon as I did it. No, that's awesome. It's I mean, there's a lot of EQ mounts out there. All beginner telescopes seem to be EQ mounts, right? And they are.
Yeah.
They're
even to the best. Paul and I spent half the night polar aligning on the wrong star one time.
It was just Sunday, actually.
Yeah.
It was. But I thought it important to bring that up because a lot of people have German equatorial mounts, and this is where they get lost. They say, well, I line my finder scope with my telescope and everything's good, but I still can't find anything.
Yeah.
Well, lots of times they kind of forgot to do the polar alignment, or maybe weren't even aware of it. So by looking at this, and you can go back and review it, and there's lots of stuff online about polar alignment, but it's a really, really important one, especially if you're going to get into doing some astro stuff, astrophotography, because polar alignment is vital. It really is. So, but for observing, it's quite a bit more forgiving.
Yeah. Perfect. Thanks, Paul. Appreciate that.
Yeah.
Okay. We're going to go now to so what I had asked back on the Harvest Moon night was or the next day, I think was, for people to send me their photos of the Harvest Moon if they had any. Well, I get flooded with photos, which was great because I love getting them. And so I just kind of put them in there were so many of them that I put them kind of together in a little collage with some background music or whatever. So we're going to try to play that now. I know you guys can't hear this, but you might be able to hear it if you turn up your phone or whatever yourselves. But we're going to introduce it anyway, if that's okay with you guys.
Lay your boots.
Okay. So let's get to that.
All right.
I want to say thank you for everybody who did submit photos. Again, as always, I love getting them. So let's see how this works. I'm gonna pause it just for a second. Oh, hang on a second. Stop presenting. No, that didn't work. Hang on.
That was quick.
Yeah, hang on. Wait a second.
Bumbo.
Okay, hang on. We're gonna go again because it started way sooner than I wanted it to. So let's try again. I'm gonna share my screen once more. Now, I want it to pop up without starting before I get started. Okay.
Oh,
Right.
wow.
Yeah, okay, hang on. We'll go back to the first. Here we go. Well, let's go to view full screen. I think I'm in full screen. Yeah, close enough.
Yeah, you are. Yeah.
Video full screen. There we go. Okay, now we can go. So,
Wow.
And that's set. Yeah. Wow, I was right.
That's all I got to say is wow, there was some amazing shots in there.
Yeah.
I was really blown away by the number of people that contributed. So I want to say thank you. Great shots, everybody. And just nice to be able to offer something like that. Like, great when I put the call out and people contribute. It's amazing.
Yeah, it's
To get to
fantastic.
see everybody's looking up. That's what somebody mentioned here. A lot more people are starting to look up now. So that's awesome.
That's crazy.
I want to say welcome to Mr. Maurice Stewart here as well tonight from Sky Viewers International. He's on here tonight. So welcome,
Yeah.
Maurice.
Yeah.
Good to see you
same
here. Thank you for sharing as well. Okay, so
Thank
we're going
you
to
for
get to what's that?
I said thank you for joining.
Absolutely. Okay, well, that's tonight's show anyway. So in closing then tonight, we'd like to thank you once again for your continued support of our efforts here. I'm going to announce, first of all, that Mark Hickox just said that it's T-minus 18 minutes for the next launch of the Starlink satellites going on. SpaceX is launching tonight. So we're just 18 minutes away, or 15 maybe, whatever. Take a tune in, might catch it. Anyway, our special thanks once again to Rosanna for her continued contributions to our program. Thank you, Rosanna. Really do appreciate it. We also hope all of those who have joined us from the Rogers Network enjoyed the program tonight. If you would like more information, excuse me, about the wonders of the night sky, you can find me at astronomybythebay.ca. Now, also a special thanks to those of you who share our program, our friends Trudy, Brad, and many more out there, Lisa, all those who share our program. We do appreciate it, and we do love getting your photos, so send them into SNAS at astronomybythebay.ca or sundaynightastronomyshow@gmail.com, and we'll be happy to include them on our next broadcast, as we already do. If you have a suggestion for a topic for a future show, please let us know too at the same address, and please let your friends and family know that we will be back here next Sunday night at 8 p.m. on YouTube and Facebook to edutain you on astronomy and the wonders of the night sky. So for now then, from Mike and Paul and myself, we wish you a safe and happy week, everybody. Lots and lots of clear skies, and as we'd like to say, guys, open your eyes to view the skies and keep your scopes pointed up.
All right.
Yep.
Good night, everyone.